Another way to solve this problem is to think about the box as it slides under its weight, so it moves under a resultant force, and this resultant force makes an acceleration, and we can say by dividing the resultant force or the weight by mass that this acceleration is certainly the g. Okay, this acceleration is g because we know that weight equals mg, but g acts in vertical direction, so if we resolve this vertical direction in direction parallel to the slope and direction perpendicular to the slope, then this motion in direction of slope will be under the component of g in this direction, which is g sine 22. Why? Because angle between two lines is like angle between the perpendiculars to these lines. The perpendiculars to these lines is the vertical line, okay, perpendicular to the horizontal, and the perpendicular to the slope. So this angle is 22, and this is g sine 22. So we can, instead of using the energy, we can use the equation of motion, perhaps v squared equal u squared from rest, so 0 plus 2a s, okay, and we choose this is because we don't have time, so we can't use s equal u plus v over 2 times t, or s equal ut plus half at squared. We don't have time for these two equations, so we just have v squared equals u squared plus 2as. Even the equation v equal u plus at also cannot be used for time. We don't have time, so this is the only equation that we can use here, and we can simply substitute s by 2.5 along the track, and we should obtain answer like this. Okay, let us comment on this graph. We can comment firstly from 0 to 10 seconds. We have here a constant of velocity, okay, because displacement time dt graph is a straight line, so its slope is a single constant value, which is the velocity, and if velocity is constant, acceleration is 0. From 10 to 20 seconds, here we have a decrease in velocity because the slope here is decreasing, and as v decreases, this means that a is negative. Sorry. Next, at just 20 seconds, which is the top here, we have the slope completely horizontal, which means that distance is constant, and when distance is constant, v is 0, because this means that object is not moving. After that, from 20 and on or greater than 20, we have the curve in this way, means that velocity is negative, okay, and when v is negative, this means motion in opposite direction, okay. Okay, here is a projectile motion. Time is needed, and we are given the horizontal distance and speed that can be analyzed or solved in horizontal and vertical direction. So theta is wanted in the time given. We can simply use the equation for horizontal motion of a projectile, where distance is simply velocity times time, and as we have distance and time, it is supposed to be an easy question, at least easier compared to some other questions in projectile. So here is the horizontal one, and is equal ut, means that 2, 9, 30 7, 5. So theta is equal to cosine minus 1. Okay. Okay. So the speed here, if you noticed, is not in the vertical direction or in the horizontal direction. The question says speed, so it means the total speed. Okay, so we have to find the horizontal and the vertical, and then find the resultant of the two components. So as in vertical direction, we have motion under constant acceleration, which is the gravity of this moon. This is g for this moon. So we can simply use the v equals u plus at. U is the vertical velocity, vertical initial velocity. This is the initial velocity, and multiply it by the sign. Let me go back. Sine theta, and we found theta to be 80.9. Okay, plus A times the time taken to reach this moon on your calculator. So to find V, we will take this number squared plus the horizontal component which is again 2460 cosine 80.9 all squared. This should give you this answer. Okay. How horizontal distance would be different, okay, on the moon. This answer can be reached by stating that they both have same initial velocity and same angle. Okay, this is stated here. Height, velocity. Okay. And as initial velocity and angle is the same, we expect that same initial vertical velocity and horizontal velocity, because again V initial will be resolved in V initial and the horizontal and V initial and the vertical. So VH and VV are the same. We have acceleration in horizontal direction again equal to 0. So VH equal to or constant. Okay. And we have acceleration in vertical direction increased because we are going to the earth here, 9.8 instead of 1.63 that we have just saw. So A in vertical direction increases, and this means that V in vertical direction increases. And as we are talking about same vertical distance cut or same height, let me make it as h, so for height. So we expect less time. Again, we have increase in vertical velocity for the same distance. So this means that it cut this distance in less time. And less time with regard to the horizontal motion, and as VH is constant means less distance, horizontal distance, this horizontal distance. So it is always a question about how to link vertical and horizontal motion together. Okay. Why students' value for speed wouldn't be accurate? Because we neglected the air resistance, and this air resistance causes a decrease in the horizontal component, and with respect to the vertical direction, it causes acceleration not to be equal to g. We have here the elastic strain energy stored in the springs are equal to work done by person and work done by gravity. Okay? So this means that E is greater than work done by person. If A equal to B and C, this means that A is greater than B or A is greater than C, especially as both A and B are positive. Okay. We have the constant to be equal F over X. Here F, which is the force on the base or the platform, as this platform is hung by 4 springs, so the weight on it downward, okay, is supported by these 4, so each one of these 4 carries 1 over 4 from this weight, because there is equilibrium, so force in any of this spring is equal to quarter the weight. So we shouldn't substitute here by 0.52, but by 0.52 over 4. And with respect to distance, it is 0.021 converted here. And we need to convert it because we should report the result in Newton meter minus 1. So stiffness of each spring would be, calculating this, 6.19. Okay. I think it is clear that to get the speed, we will use the energy conversion. We have here elastic energy, and as the bread goes down, there is gravitational potential energy, and both of these energy will be converted to kinetic when we release, or when the hook is released after hitting the bread. So we basically have kinetic energy equal to elastic energy and GBE. Okay, certainly delta GBA. So we need first to find E, and we know that E can be half kx squared, but we will need x. Someone may say that x is given in the previous part as 2.1 centimeter or 0.021 meter, but this is when only a force of bread weight acts on the platform. But here, as we have another downward force, 1.2 Newton, exerted by the hook, we need to recalculate x to know the new x when both weight of bread and hook force are exerted. So we will start from x equal f over k, substitute f as 1.2 by hook, 0.52 by weight, divided by 4, because don't forget that the platform is supported by 4 springs. And this is divided by k, and k was calculated 6.19. Okay, so the answer here, okay, we can then find E. This gives okay, Joule. But this is for just one spring. And as we have 4 springs, so a total is 4 times the answer for one spring. Okay, this should give you 0.0598 joule, and then we go for finding a value for the kinetic energy of the bread. Kinetic energy equal this value plus the change in GBE. The change in GBE here is from a lower to higher value. Okay, I mean we began by the platform down and then it goes up. So this means an increase. This increase should be subtracted from E. So again, we started with just E, okay, stored in the 4 springs, and as the lock is released, it goes up, so the platform acquires delta GBE, and it acquired this delta GBE on expense of E, so it should be subtracted from it, and the remaining is given to KE. Okay, you can avoid any confusion here by making it as a minus, okay, and it will also be correct. Okay, so you can make here a minus, and delta GBE is mg, which is the weight of the bread and the platform. Platform is massless, so it is weight of bread times the distance moved, or the extension in spring that is removed and spring returns to its original length. This extension was calculated for new forces just as this. Okay, if you do your calculation, you will find the answer as joule. Last step is to equate this value with half mv squared, or to arrange just like 2 over m times this value. Okay, to find m, again we have the weight, so we can just divide the weight by 9.81. Okay, 0.52 over 9.81. You can do this directly on your calculator by using the fraction, or you can make this to the numerator here whatever you like, should give you the value of 0.946 meter second minus 1.